Now let us see what is spectral efficiency or bandwidth efficiency of all the M-array modulation schemes which we have discussed. We have discussed M-array PSK schemes, FSK schemes as well as COM schemes. So first we will see what is spectral efficiency and then we compare spectral efficiency of various M-array modulation schemes. So if you just take any M-array modulation scheme, any M-array transmitter transmits M possible signals and it carries, each of the signal carries how many information bits? Log 2 M number of information bits, and the time duration taken by each of this is log 2 M TB. Therefore data rate would become the rate at which we are transmitting data to the channel is number of information bits divided by time. So since we are transmitting log 2 a number of bits and time it is taken is log 2 mtb seconds, therefore the data rate which we are transmitting to the channel is 1 by 2 bits per second. And now we want to see what is the bandwidth occupied by this signal. So if you remember that if it is MPSK signal, the rate of all the M-array schemes will be same, but the bandwidth required will be different by each M-array scheme. So first start with MPSK, and we have seen that bandwidth occupied by MPSK signal is 2 by log 2 mtb or 2 by ntb, and so therefore bandwidth efficiency becomes which is number of information bits transfers in per unit time and per unit bandwidth. So the information which you are transmitting to the channel in per unit time is called data rate, and if it further divided by bandwidth then it is called bandwidth efficiency. So bandwidth efficiency for the PSK scheme would become data rate which is 1 upon TB divided by bandwidth which is 2 by log 2 MD. So if you change this sign you have to just swap it, log 2 mtb cross 1 upon TB cross log 2 mtb by 2 and TB gets cancelled. So bandwidth efficiency of MPSK schemes is log 2 M bits per second per hertz. And as what is the conclusion? We see as M increases, the bandwidth efficiency of MPSK scheme increases. Similarly, we can find out bandwidth efficiency of a MQAM scheme. Again, the formula is same, data rate which we transmit to the channel in per unit time and per unit bandwidth. So per unit time is log 2M divided by log 2M into TB, and bandwidth occupied by a QAM signal is same as the bandwidth occupied by the MPSK. So of course bandwidth efficiency of QAM and bandwidth efficiency of the PSK would be same. Okay. So we have seen bandwidth efficiency of the PSK as well as COM scheme. Next, we'll see bandwidth efficiency of M-array FSK scheme. So of course, as I told you, data rate for all the M-array schemes is same, log to a number of bits transmitted in NTB number of 9 TB seconds, so bits per second, and this is division per hertz, and this is the bandwidth of the MFSK scheme, which we have studied in our previous class, that bandwidth occupied by the M-array FSK signal is M delta F, where delta F is 1 upon 2 NTB or 1 upon 2 log 2 MTB. This we have seen. Therefore, if you just solve it, this division sign will becomes cross, and you just write it as 1 upon delta F and put delta F as 1 upon 2 NTB and solve it. It is very straightforward that you will get 2 log 2 M by N, and so bandwidth efficiency of FSK scheme would be 2 log 2 M by M. And one important fact is, as M increases, the bandwidth efficiency of FSK scheme decreases, whereas for QAM and for PSK, as M increases, the bandwidth efficiency